Guys, in last video we wrote this code, and in this video today I'm going to debug this code, and then after you will realize how this code is working recursively. Okay, before that I'm going to tell you why I wrote this one. Okay, n equals to this, n equals some values here, and I'm going to divide into this problem into subproblem. Suppose I'm thinking like that, I want that the nth Fibonacci series for some value. Suppose my nth is given fifth, I want this fifth value. So what happened, this fifth value is depend upon last two value, and this three value, the result of this problem is that three values depend upon last two value, means 2 and 1. This like that, this is my problem. So what happened, every time what I'm doing, that problem is to divide it into sub problem, and I'm saying please tell me the value to me. So what happened, this function is calling, that function is reduced into two sub problem, and that problem is reduced further, that problem is reduced into sub problem. And what happened, and finally whatever the result will come, that result will attached, and that value is goes to the parent, and parent is again returning to that parent. Okay, so using that manner, that output will come. Okay, so I'm going to debug this code. Okay, one thing. Okay, yeah, one thing is what, this Fibonacci series of this function is calling and again and again. See, over here also, over here also. So what happened, due to this, the time complexity will increase, and if the time complexity will increase, what happen, my performance will reduce. To optimize this solution, we will store that some value into some storage memory, and if we will store that value, what happen, whenever I want that particular result, I will copy that one, and further I'm not going to call these things. Okay, so debug this code first. Yeah, here you can see that my function is calling. Yeah, for value Fibonacci series with n equals to 5, this is going to be called. Now my pointer is here, now n equals to 5, the function is going to be called. Now what happened, every time the stack frame will created, and after completion of that particular function, it will pop that stack frame, and it will come out with the some values, it will return some values. Okay, so what happened, n equals to 4, this is going to be called. Till now this is not going to be called. Okay, first this function is completed, then after this will call. Okay, so what happened, so n equals to 3, this is going to be called. Okay, 3, then 2, then what, 1. Okay, so n equals to 1 is here. Now stack frame is created. Now what happened, now stack frame is going to be popped out with some return value. Okay, so when n equals to what, n, so what happened, it will return what value, 1. Okay, so now this is going to be returned. So what happened, this value is going to be returned from here with the value 1. Okay, see, this return what value, with 1 return. Okay, now this come to that previous stack. The previous stack value is what, 3. This stack is containing value 3, this containing 4. So now the pointer is in that particular value n equals to 2. So this will return again, this will call for this function. Okay, see, now here again, that again stack is created with n equals to 0. So what happened, every time that stack is created, and that after solving that problem, this will return some value, and that memory will pop up from that stack frame. And using this thing, you can from this solution or from this code, you can understand, or you will capable, or you will able to understand that the problem is taking the exponential time, due to every time for n equals to 2, it is calling 3 times. Suppose if I will increase the n term to 1000 or 10,000 times, so what happen, every time that some particular function is calling again and again, so what happen, our system will take or generate more time, means it will take more extra time. So time complexity will definitely increase. Okay, next video I will add the dynamic code, dynamic programming. Okay. In next video you will see that.